5.1 Momentum and impulse. Okay, what is the momentum? We call it P. P is mass multiplied by the velocity. No, velocity is a vector multiplied by the mass, which is a scalar, give you a vector. So the momentum is a vector quantities. The unit for the momentum, mass, the unit for mass is kilogram. For velocity is meter per second. So the unit for the momentum is kilogram meter per second. Okay. In 2-dimension, we can talk about the momentum in x direction, momentum in y direction, and we do the questions. Linear momentum, as is the product of the mass of moving object and its velocity. And its vector quantities, as we talked about. Now look at that. Determine momentum of specific layer back. The mass is given, so velocity is given. So easy. Mass multiplied by the velocity, that gives you the momentum. Can try question 1, 2, 3 here. Okay, we can prove that mass and force has some relationship with each other. Total mass is equal to total force is equal to mass multiplied by acceleration. Acceleration is change in velocity over time. V final minus V initial divided by time. You can move the time to the other side, so it's going to be force multiplied by time. And it's mv final minus mv initial. Means mv is momentum. So it's momentum final minus momentum initial. Therefore, change in momentum is force multiplied by time. We call force multiplied by time, we call it impulse. Or we can say impulse is change in momentum. Okay. So here, as we rearrange force is change in momentum divided by time. If you have momentum time graph, the slope of momentum time graph give you the force. If you have force time graph, the area under the force time graph will give you the momentum. Now, here is another question. A baseball mass of 0.152 kilogram traveling horizontally at this is velocity is given. Collide with the baseball bat. The collision lasts for 1.15 seconds. The time is given. Determine the initial momentum of the baseball. Let's travel horizontal at that. So this is final velocity. We have initial velocity. So we can find initial momentum. Mass multiplied by velocity. Mass and initial velocity is 37.5. The initial momentum. Now, what average force apply on a bat? Knowing that the force is momentum, changing momentum over time. F initial and final velocity, we can find changing momentum. mv final minus mv initial will be changing momentum divided by the time that is given. So you will get the force. Determine the ratio of the magnitude of this force to magnitude of the force of gravity. Of course, force of gravity is mg. The force that we got here divided by the force of gravity is 7.72 10 power 3. This is the ratio between the force and force of the gravity. Here's another example. A 57-gram tennis ball is thrown upward and then stuck just as it comes to rest at the top of its motion. The racket exerts an average horizontal force of 0.2 10 power 2 on the tennis ball. The tennis ball fell after the collision of its average force exerted on the ball for 4.5 milliseconds. So we have force, we have time, we can find change in velocity. Knowing that the initial velocity, we have some initial velocity, but the final velocity will be zero because at its maximum, it will come to the rest at the top of its motion. So just rearrange it for mv final. Sorry, v final is zero. Rearrange it for mv initial, for v initial. So mv initial to the other side become positive, f delta t to the other side, it become negative, and we have a v final here. So this is zero. We just put the number v initial will be given. So we take our question assuming the time interval is, so you do the same thing with a different time. And that's it. So you can do question 6, 7, 8, 9, and 10 as a practice.